Hey AP Stats, we are going to do a couple of pages of notes today, and we are talking about the measure of relative standing. Okay, so it's kind of what this whole chapter is about, is figuring out how far away values are from the mean. Okay, so standardizing means that we're converting values from their original values to standardized units. Okay, so we're getting rid of their whatever units they're in so that we can just determine how far away something is. This is also known as a z-score. This shows how many standard deviations away a value is from the mean. Okay. So this is the chapter that we're going to start to talk about interpreting standard deviation. Last chapter we were more concerned with just being able to physically calculate it. This is now where we dive into what does it mean and how do we use it. Okay. So a z-score is you take a value minus the mean and divide by the standard deviation. Okay. In symbols, x minus mu. Okay, this symbol is called mu, which is mu. Mu, it's a Greek letter. And then you're dividing by, this is a lowercase sigma. Most of you know the uppercase sigma, it's like the summation symbol, but that's a lowercase sigma. Okay, so that's our standard deviation. Although out of the calculator, we're always still going to use the s sub x out of the calculator. So that's just a side note. Okay, displayed below are 25 test scores from the first statistics test. The bold score is Erin. How did she perform on the test relative to the rest of the class? Can we say that she was above average? Okay, so her score has to be standardized, which means we have her score, but we need to know the mean and the standard deviation. So what we're going to do is put this into the list. So go ahead and get this data in the list. And then we can do like one variable stats to find the mean and the standard deviation. So you go ahead and get your calculator going, get that data in the list. Okay, so when you do one variable stats, what you should get is our x bar, the mean should be 80, and the standard deviation that we get out of that should be 6.07. Okay, so the z-score, we take her value, 89, minus the mean, divide by 6.07. So is her score above or below the mean? It's above. So your z-score should be positive. Are you going to have values that are below the mean? Yeah, just not this one. Like take any of the people who are in the 70s. Those are lower than the mean. So sometimes z-scores are going to be positive, sometimes they're going to be negative. That just means they're above the mean or below the mean, so it's perfectly fine. So when you calculate this, you should get 1.48. So check with each other, make sure nobody had like technical difficulties with that. So what can you say about how Erin did on the test relative to the rest of the class? Well, this is kind of basically like interpreting a z-score, which is a big thing for this chapter. So Erin earned a score that is 1.48 standard deviations above the class average. Okay, so a big thing in this chapter is, again, z-scores can be positive or negative, so they have direction. You don't want to just say it's 1.48 standard deviations away. Okay, some students are going to do this. Don't do that. okay? Because we can tell if it's above or below. So you want to say that. It's above here, the class average, okay? All right, consider Tyler, who's earned a score of 72. What can we say about a score of 72 relative to the rest of the class, okay? So we've already got the mean and standard deviation, so we're just going to find another z-score. So 72 minus 80 divided by 6.07. Okay, so go ahead and calculate that. You should get negative 1.32. Again, it's negative, it's below the mean. So what can we say about that? Same thing, like Tyler earned a score that is 1.32 standard deviations below the mean. Okay, notice that I just left 1.32 as positive, but then I used the direction for below. Okay, so it's 1.3 standard deviations below the mean. So just visually you can see, like, we're going to start to talk about how spread out things are. So 1 standard deviation on either side versus 2 standard deviations on either side. Okay. All right, once values are standardized, they can be compared. Okay, that's kind of the whole point of this. All right. We're going to skip this little part called Chebyshev's rule, and we're going to do that in class together. So let's jump on down to normal distributions. Okay, so some of you may have heard of a normal curve or may not. It doesn't really matter either way, but you just may have heard that description. So we're going to break down what a normal curve is. A normal curve is a particular density curve that is symmetric, single peaked, and bell-shaped. So symmetric, single peak, and bell-shaped. Normal curves describe normal distributions. Okay, and normal curves follow particular rules for how much data is close to the mean and how much data is far away from the mean. They're very, very specific. Okay, sometimes also you'll see an abbreviation that is something like this, or it looks like a capital N, and then they'll put a number inside the parentheses. So say it's, I don't know, the last one we did was 80, 6.07. So that means a normal distribution with a mean of 80 and a standard deviation of 6.07. Okay, so if you see that shorthand notation, that's just telling you the mean and the standard deviation. Okay, so an empirical rule is the first thing we're going to talk about. It's an estimation. So we're not always going to solve it like this, but to get the hang of it, we're going to use this. We will find exact numbers of standard deviations in the next section. So approximately 68% of the observations fall within 1 standard deviation of the mean. Okay, so within 1 means above and below, 1 in each direction. Approximately 95% of the observations fall within 2 standard deviations of the mean. And approximately 99.7% of the observations fall within 3 standard deviations of the mean. Okay, so let's look at this. 68%. So that is the middle 68%. So if here's the mean, my middle 68% of my data is right there. All right, so very similar to the other ones. 95%, again, we're anchored in the middle, 95. So we go 95 each direction, 95 from the middle. So there's, split that in half, but. All right, and then the last one is almost everything, not quite, I mean, it's 0.3%, and it stretches 3 standard deviations in each direction. Okay, that's your 99.7. Oops. Sorry about that. I'm not really sure what I just did. Okay. Okay, and then something that comes up in this section is what are called percentiles. And you've probably heard of the word percentile because when you guys take like standardized tests, a lot of times they give it to you, your results in a percentile. So maybe on your standardized test, you were in the 94th percentile. That means that you scored above 94% of the other people taking the test. Okay. So percentiles are defined such that the pth percentile of a distribution as the value with the whatever percent of the observations are less than or equal to it. So like what I just said, you're in the 94th percentile, say for math on a standardized test. That means that you scored in the top 94%, or like you scored, your score is, so your score corresponds with 94% of people scored that value or lower. I got all tongue-tied right there. Okay, so that you scored, yes, that score or lower for 94% of people. Okay. Okay, so first example, an article in Biometrica looked at 1,052 heights of mothers and found that the sample mean was 62.5 inches and the sample standard deviation was 2.4 inches. The data distribution was approximately normal. Okay, so here's a big thing. Draw a curve and label the values that correspond with the empirical rule. Use the empirical rule to answer the following. So we are just doing the empirical rule, okay? So basically that little graph that we had up above. So we're going to put our mean down here, not that, at 62.5. Okay, and then to the right, we're going to go up one standard deviation. Okay, so one standard deviation is 2.4 inches. So when you add that on, we're just going to be at 64.9. And then I'm going to add on another standard deviation, and then add on one more. Okay, so we're just going up by our standard deviations, and I'm going to go down. So we're going to go down one standard deviation, then go down again, and then down again. So I'm just subtracting the 2.4, which is the standard deviation. Okay, so we said that 68% of our data is how many standard deviations away. It's one standard deviation. So what we do is, I'm going to draw this up, sort of vertical lines. And so the data that's in between here is going to be 68%. Okay, it's one standard deviation away. The next one is 2 standard deviations away. So I'm going out now, down 2 standard deviations. And this, the amount of data in there, makes up 95%. And then the last one is 99.7, goes almost all the data. Okay, so that's drawing it out based on the empirical rule. So now we're going to answer some questions based on this curve. So what percent of the mothers were between the heights of 60.1 and 64.9? Okay, 60.1 and 64.9, do we see that? Lines up? Yep, 68%. What percent of mothers' heights exceed 67.3? Okay, so here we're talking about greater than 67.3. 67.3 is anchored to the 2 standard deviations away. That is the 95%. Okay, so again, the 95% is the middle 95%. So if I wanted to figure out, so it's like the middle, what percent is left on each side? Well, by definition, this is a density curve. So we know that the whole area under the curve is going to be 100%. Okay, so if this is the middle 95, there's 5% left over, and then we have to split it between the two sides, meaning there's 2.5% on each side. Okay, so when we look at this, like up here, going this way, there's going to be 2.5%. And when we go this way, there's 2.5% to get to 100%. So what percent of Mother's Heights exceed 67.3? That's going to be 2.5%. Oops. All right, what percent of Mother's Heights were less than 60.1 inches? Okay, so now we're going less than. We're just looking at one of those tails, and so up here, 60.1 corresponds with that 68%. So we're going to do the same strategy. So if this is the middle, 68%, what percent is left over? 32%, and we have to split that between two sides. So that means that this direction, there is 16%, and this direction, there is 16%. Okay, so what percent of Mother's Heights are less than 60.1 inch? That would be 16%. All right, a height of 57.7 corresponds with what percentile? Okay, so remember the percentile is the percent, I just want you to remember it to the left, lower than. Okay, so 57.7, if we go back and find that up here, 57.7 is down here on the lower side. What percent is going to be the same as this or lower? This corresponds with that 2.5% that we found. So it's the 2.5th percentile. Okay, percentile always means less than, to the left. Okay. All right, and then a height of 64.9 corresponds with what percentile? Okay, 64.9 is over here. It's above the mean, so we're here, 1 standard deviation above. So what's the total percent to the left? Okay, so this is tied with the middle 68%, but is that everything to the left of it? No, we have the middle 68%, and then what's below that is that 16%. So really this percentile is going to be, if we add 68 plus 16, so we get 84. So this is the 84th percentile. All right, high school dropout rates is in percentages for the period of 1997 to 1998 for the 50 states were given in the Chronicle for High Education and are shown in the following STEM plot. And the STEM plot just is broken up more than just like high-low. It's just separated more. That's all you really need to know about this, okay? So like one dot represents 10 and 11, one T represents 12 and 13, one F, 14 and 15, etc. So it's just broken up a lot more. Really what we want to look at here, the details, the mean dropout rate is 9% and the standard deviation is 2.4%. That's really what we care about, okay? Okay, so part A, the empirical rules suggest that 68% of high school dropouts, dropout rates are between what two values? Okay, 68% corresponds with how many standard deviations? 1 standard deviation. So it's plus or minus because we're going above and below 1 standard deviation from the mean. Okay, so we're going to take our mean of 9% and then plus or minus 2.4%. Okay, so high school dropout rates are between what? They're between 6.6% and then add that on to 11.4%. 1 standard deviation. And then we'll come back and solve this once we go over Chebyshev's rule in class.